You've heard us talk a lot about 3D printing lately, and some of those terms you may not know. Well, let's get down to basics. Welcome to 3D Musketeers. My name is Grant. I'm joined by the ever-effervescent Victoria, and we are here to talk to you about hot ends and some of the basic stuff involving 3D printing because, well, we've used a lot of terminology like FDM, FFF, CJP, MJF, and some of those are in this video, some aren't. We're going to have a whole series about getting back to the basics so that if you are looking to get into 3D printing, that you'll know the terminology when it comes time to know it. And if you want to see more videos like it, let us know. Get subscribed because they're coming. Don't forget to hit that like button while you're down there. But let's talk a little bit about FDM 3D printing. It stands for Fused Deposition Modeling. We love this technology. It's actually technology that you see running behind me right now. And a lot of the parts that you see made here at 3D Musketeers are made with FDM. Fused Deposition Modeling is technically still copywritten by Stratasys. So the industry has adopted the term FFF, Fused Filament Fabrication. There are a few key components in this. You have your hot end, which if it was actually connected and on, this would not be possible if I wanted to keep feeling in my fingers. This is the business end of an FDM 3D printer, the hot end. Now, could be a little bit different than the one that you have. You might have a volcano style with a longer heat block, but they all still work the same, and yours may not look like this. That's totally okay. We want to go over the key characteristics of a hot end, how it works, and why. I guess we'll start pretty easily with the nozzle. The nozzle is the tip to your 3D printer. It is a replaceable, serviceable component. It has a small little orifice. Might be easier if I show it in that direction. It's got a little tiny orifice. This one is 0.4 millimeters. You can get them as high as almost 2 millimeters for your standard 3D printing. But the general standard is 0.4 millimeter. It is a great combination of quality and speed. It can go as low as 0.05 millimeter layers if you don't care about time, and as high as 0.35 millimeters if you care about time, not too much about your quality. The nozzle threads into the heat block. So let's take the bottom portion of, or I guess this would be the top portion, but the bottom for you, for the heat block. The heat block is where your heater goes. This is your heater. These are generally somewhere between 30 and 60 watts. They are incredibly tiny. You're looking at, something that's maybe an inch long, maybe a little bit less than an inch long, and by about 1/4 of an inch in diameter. This one is a 40 watt, 24 volt. So it runs on 24 volt 3D printers. We have our 12 volt and 24 volt. The industry is moving toward 24 volt. It is safer overall because you have less amperage to get the same wattage. If you are looking to learn more about that, we're going to have a video coming shortly as well to figure out what is the best hot end for your 3D printer. These things are your problem because unregulated, you have some issues. Well, Grant, how do you regulate this? Well, hey, I'm glad you asked. You use a thermistor. A thermistor is like a thermostat, but not. It's a thermistor. The best way to describe this is the hotter it gets, its resistance changes. It can go up, it can go down, depending on the type of thermistor. These are 100K thermistors, and they help the printer understand what temperature it is at. If your printer runs, if you unplug your cables for your thermistor, you don't have a 3D printer, you have a house fire. And if you're wondering what 3D printer we should get, hey, we have a video on that as well. Card will be right there. These two tools enable a 3D printer to function just like your hot glue gun needs to heat up, but then it holds a temperature. The thermistor is what helps on that in a 3D printer. It's a little bit different. There's a lot of technical stuff that goes on here This is beyond the scope of this beginning course, but if you want to see that, let us know in the comments below, because, yeah, I'll do a course dissecting these and show you what they are and why they matter. So now we know what goes into the heat block, but what is the heat block? The heat block is, well, where the heat is concentrated. And you have your hole for your thermistor, which is on this side, and your hole for your heater, which is right here. And you use a screw to clamp in your heater, and a little grub screw, which is little tiny thing. I will hold up both screws in their bag so you can see how tiny they are. You will lose them. Buy spares. The most popular company for this style is E3D, and actually we are showing a V6 variant. I don't have any real V6s on hand. They're all actually in the printers right now, but we do keep some clone parts in stock just in case we really need something. It's actually cheaper, funny enough, for the clones to buy the entire Hotend than it is to buy a heater, a thermistor, and a nozzle separately. So we end up with lots of spare parts that we don't use. Like these gold heat sinks are, depending on your preference, you might think they're gaudy, you might think they're cool. I don't particularly like them. I just don't like the color. I mean, it's not the gold that I would want, and it's not the polished aluminum that E3D uses. And then between your heat block and your heat sink, you'll see there's a little thing sticking out. It is called a heat break. A heat break, as you can see, next down in the middle. And that enables heat transfer, but not a ton. You don't want a lot of heat getting up into your heat sink. The goal of the heat sink is to get rid of that excess heat. But if you were transferring all of the heat, you'd have a bit of a problem because, well, yeah, you wouldn't be able to heat up the filament. Your goal of the 3D printer is to keep as much of the heat contained in this little rectangle as possible. To do that, and of course I don't have one for the V6, but I do have one for a volcano head. Sometimes we use silicone socks. It's just a piece of silicone that fits on and basically not only protects your heat block from errant strings of material. If you do have a failure, it prevents the blob of doom. It also keeps the heat where you want it in the heat block. This is great if you're running lots and lots of cooling, which in some of the materials you will have. And if you're wondering what materials can I print, well, hey, you're in luck. We have a video coming up soon. Get subscribed so you don't miss out. The heat breaks can be made generally out of aluminum. So stock, they're normally aluminum. Stock, the heat blocks are aluminum, and stock, the nozzles are brass. But all of these you can upgrade. You can go to a titanium heat break, which of course doesn't transmit heat as well as aluminum, so you get less heat moving into your heat sink and more heat staying into your heater block. You can get blocks that are made of copper versus ones that are made of aluminum, but be warned on those, they can be a little picky on lower temp materials like PLA. We actually had to take on our time-lapse printer behind me the copper block, titanium break, and tungsten carbide nozzle and convert it all back to stock if we wanted to run PLA effectively. Now, your results may vary, but that's my personal experience. Nozzles come in a variety of materials similar to your heat blocks, but way more options. The standard is brass, and that's basically good enough for all materials that you as a beginner might be using. But when you start looking at glow-in-the-darks, wood fill, and other abrasive materials, you need to look away from brass and into other metals. There is stainless steel, which is a little more abrasion resistant than brass, but if you're going to spend money on a new nozzle, get that hardened steel. E3D makes a wonderful nozzle called the Nozzle X, which comes with a lifetime warranty. But my favorite nozzles, and they are very expensive, are made of tungsten carbide, the paragon of metals. This volcano actually has a tungsten carbide nozzle on it. It is a spare for one of our printers that does tend to burn through nozzles a little faster than others because its entire duty is to print high-end filled material. So always keep a spare on hand. Nozzles are important and they are a rare item and they can get clogged. And a great way to unclog them is actually, funny enough, acupuncture needles. You can buy them on Amazon and you can put them into your nozzle when it's nice and hot to try to unclog it. If you are clogging nozzles, you might have an issue. If you are clogging nozzles and you're dealing with this problem and you found this video, let us know in the comments, because I want you to send me some photos and we're going to talk about it in an upcoming series all about printer failures and what actually caused them. If you are wondering how to assemble this, a lot of it does need to be done at heat. That does, of course, involve having a heater inside, having a thermistor inside, and it being completely hooked up and wired to a 3D printer. If you want to see how to do that, we'll do a whole series on how to hook up parts on a 3D printer. As long as you all would like to see it, let us know in the comments as well. When you put things together, though, it needs to be hot. You screw in your heat break until it is flush. The small threads go into your heat block until it is flush. Some people say you can put your nozzle all the way down, undo it 2 turns, and then butt your heat break up to it. Once it's done at heat, you'll be great. You can do it when it's cold like this, get everything together, put it into your printer, heat the snot out of it, and then go ahead and tighten everything up. But be warned, you can break these. You can really break them and have yourself a bad time. So it is always good to have spare parts. E3D makes a real version of this. They are phenomenal to have. If you are buying a 3D printer with an E3D Hotend, we highly recommend you look at making certain that you have at least spares of your nozzle, your heat block, and your heat break. We've not seen many instances where your heat sink will break, but sometimes, yes, it is cheaper just to buy the whole darn kit as one. And of course, these are open source. That's why clones exist, but take it with a grain of salt because clones are not always made equal. But when you look at it, it's basically a hot glue gun, right? It's got a motor that's pushing your filament through. It's getting the snot heated out of it here. It's coming out of the nozzle. There's a fan that cools it down. And then it's duct taped to a computer-controlled Etch-a-Sketch with a Z-axis. There you go. That's basic FDM 3D printing. If you have any more questions about how things work or what they do, let us know in the comments. My name is Grant. This is 3D Musketeers. Victoria is off doing important cat things, but we hope you enjoyed this video. Don't forget to call your loved ones, and as always, keep making awesome. Have a good one. Come on. You can't beat lifetime warranties. Tommy Boy reference. Oh yeah, let's do it.